Okay, today we are looking at dividing polynomials. It's kind of an extension of yesterday's lesson. Yesterday we divided monomials. What's a monomial? It's like one cluster of stuff. It could have had several different coefficients and letters, but it's still one cluster of stuff. In other words, there's no adding or subtracting. Well, today we're going to look at dividing like a trinomial by a monomial. I'm sorry, a trinomial by a binomial. But before we get into that, there was one thing that I wanted to touch on that I meant to do yesterday, but we kind of ran out of time. And that's what happens when you've got an exponent of 0. Okay, for example, what's 4 over 4? 1. What is 3 times 2 over 3 times 2? 1, right? What's x over x? Not 1x. It's just 1. What would x squared over x squared be? 1. So my point here is if you have the exact same total on your numerator as you do on your denominator, what's your answer always going to be? 1. So keep that in mind when we think about our exponent laws. If we did, this is what we did yesterday, x squared over x to the 1. What would that be? That would be x to the 1, right? Because 2 minus 1 is 1. So when you're dividing powers of the same base, the exponents get subtracted. So what if we had x to the third over x to the third? That's absolutely a 1, because we have the exact same total on top as we do on bottom. But what if I wanted to write it with a base of x? That would be x to the what power? 0, because what's 3 minus 3? 0. My point is that anything raised to the 0 power actually means that you had the exact same total on top and bottom, which is a 1. So if you have an exponent of 0, that does not mean 0. It means 1. Anything raised to the 0 power is 1 because of this law right here. Because when you subtract these exponents that are exactly the same amount, you get a 0 here. Anything to the 0 power is 1. So what's 5 to the 0 power? 1. What's 28 to the 0 power? 1. What's negative 17 to the 0 power? What's 1 million to the 0 power? What's x to the 0 power? 1. Okay, so that's part of the lesson I wanted to include in yesterday's notes, but I didn't. So anything to the 0 power is 1. That's just something you got to memorize, something you got to know. Now, let's get on with today's lesson, which it's not hard. Today's lesson is pretty easy as well. We're dividing polynomials today. Divide x squared plus 8x plus 12 by x plus 6. There are several different ways to represent a division problem. One way is they can write it out in words. Divide x squared plus 8x plus 12 by x plus 6. Another way is to convert that into a fraction, and that's usually how I would encourage you to write these problems. A fraction bar is a division symbol. And it's going to make our lives easier if we write these as fractions. And it looks similar to what we did yesterday, but it's not exactly the same. Now, first thing you got to figure out is what goes on top. No, this is the numerator, because that's what is being divided. What goes on top is what is being divided. Well, if it's written like this, it's whatever comes after the word divide. Kind of like the ones where we were subtracting, whatever comes after the word subtract. So this is my numerator. Not because it's bigger, but because it came after the word divide. Yes. We'll do one of those in just a minute. What is the denominator is what you are dividing by. We want to divide all of this by x plus 6. Now, this is not the same problems that we did yesterday because these problems have pluses and minuses in between the terms. Some kids are tempted to like reduce the 6 and the 12. Or maybe reduce these x's. Or maybe this x and this x squared. And I'm telling you, you cannot do that. Because the only way you can reduce a fraction is if you reduce a common factor. Well, right now, x plus 6 is not a factor because x is connected to something else by a plus, not by a multiplying. And up here, we've got a bunch of stuff connected by pluses. So I cannot just start canceling out when it's written like this. What you can do, though, is look at this and see if we can write it in a different way. What have we done with trinomials? What have we been doing for months, it seems? Well, GCF, but is there one there? No, so what do we do next? We would factor it. So factor it. Factor the numerator. We're going to rewrite the numerator in a different way. We're going to write it as factors so we can hopefully find some common factors and cancel them out. So remember, what goes here and here has to give you x squared, x and x. We're looking for the factors of 12 that could add up to an 8 in the middle. And what do my signs have to be? Plus, plus. So this would be x plus 2, x plus 6. Now, this is what I am allowed to do. Do you see how x plus 6 is connected to x plus 2 by what? No, in between here is multiplying. So now I've got a whole x plus 6 factor, and on the bottom I've got a whole x plus 6 factor. Guess what I can do with those guys? They can cancel out. So what am I left with? X plus 2 over 1, which we would normally just write as x plus 2. So that is very different than what we did yesterday. That's all you got to do. Now, let's talk about what this would have looked like. It does not really get very much more difficult, no. What if this had said divide x plus 6 by x squared plus 8x plus 12? It's a similar answer, but it's not the same answer. In this case, the x plus 6 is on top because it's what's being divided. And what I'm dividing by is now x squared plus 8x plus 12. Same process, though. I can't cancel out any of these x's or the 6 and the 8 or the 6 and the 12 because it's all connected to other stuff by adding. So I've got to factor this. And it still factors into x plus 6 times x plus 2. I can still cancel out the x plus 6's, but what's my answer now? 1 over x plus 2, which is a very different answer than what we got a second ago. If the numerator completely cancels out, you must replace it with a 1. You cannot just drop it off. If the denominator completely cancels out, you could write the 1 or you could not write the 1. It doesn't matter. Because dividing by 1 doesn't affect anything. But we're not dividing by 1 in this case. We're dividing 1 by x plus 2. So you have to write it like this. 1 over x plus 2. Do you see the difference? So this was x plus 2 over 1, which we just write as x plus 2, but this one was 1 over x plus 2. Okay, number 3, let's just look at a different way they might write the question. Y'all remember elementary school, this little symbol? The house symbol? X squared minus 10x plus 9 is getting divided by x minus 1. And there is a way to work this out using the division bar symbol, but what I'm going to encourage you to do is to rewrite this as a fraction. But you got to know what goes where. What goes on top? X squared minus 10x plus 9, because that is what is being divided. What am I dividing by? X minus 1. What you are dividing by has to go on the bottom. Can I start canceling out x's? No, because they're connected to other stuff by adding or subtracting. What can I do, though? I can factor the top. And guess what? These should be rigged where something will cancel for you. So it's kind of like what you're dividing by. Your divisor down here should be a clue as to what one of your factors most likely will end up being. For example, when I start to factor this, 9 could be 9 and 1 or 3 and 3. Well, look at my denominator. What do you think it's going to be? It's going to be 9 and 1. Plus, we need to make a 10 in the middle, and a 3 and a 3 will not make a 10 in the middle. What do my sign combinations have to be here? Negative, negative. So what is this going to factor into? X minus 9. And sure enough, x minus 1. That would give me x squared, and then I'd get a negative 1x and negative 9x. That's how I get the middle term, and I'd get a positive 9 on the end. Now, do I have any common factors? So now the entire x minus 1 factor will cancel, and what am I left with? X minus 9. not that bad. That's pretty much it. All right, you try these problems. I'm going to write them the 3 different ways we've talked about. 3x squared minus 8x plus 4, fraction bar x minus 2. Y squared plus 12y plus 20 divided by y plus 10. No, one more. Let me find one. Let me find a good one. And then one like this. This is as much as we're going to kick it up. I'm not lying. Alright, so here's the 3 ways you might see a division problem represented. You've got to put it in the right order on 5 and 6. And then factor away and see if something cancels. And again, use what you're dividing by as kind of a clue as what one of your factors will probably end up being. That can kind of help you with your factoring. It can help you kind of eliminate some of the guessing and checking. Do y'all know what I'm talking about when I say that? Yeah, kind of. Like when I start factoring this top one, I know it's got to be 3x and x. Oh, yeah. Look at my denominator. What do you think I might get as one of my factors? Well, I probably am going to have an x minus 2 factor. Which means this would also have to be a minus 2, and let's see if that would work. That would give me 3x squared minus 6x minus 2x. That works. And then a plus 4. So it kind of helps me with my factoring. Is it the same question? Oh, sorry. Let me give you a hard one. Oh well. See, I told you it wasn't going to get any more difficult. So these cancel out and you have 3x minus 2. Was this the same one? Yeah. Oh, wait. No, they're the same thing. You are kidding me. I just looked this one up in the book. Okay, let me change that. 10y squared minus 19y plus 7 divided by 2y minus 1. How about that? Okay, did y'all figure out the factors for number 5? Yeah. Y plus 10 and y plus 2, and that's getting divided by y plus 10. So then we're able to cancel out that whole y plus 10, and we're just left with y plus 2 for this one, right? So if one of my factors is probably going to be 2y minus 1, what would the other one have to be? Because think about it, we're trying to make a 10 here. So if 2y is one of them, the other one would be 5y. And we're trying to make a 7 here, so if this one's a 1, the other one would probably be a 7. You see what I'm saying? How this can give you hints on how to factor? So if 2y minus 1 is going to be one of my guesses, then I would have to have a 5y here And I'd have to have a minus 7 here. Now make sure it works. That would give you 10y squared minus 14y minus 5y, which does give you negative 19y. And then you'd get a plus 7 on the end. So yeah, this hint did help me with my factoring. So this is being divided by 2y minus 1, and I can cancel out common factors. What am I left with? 5y minus 7. Okay, and before we talk about homework, I want to do a little bit of review because you are taking a quiz tomorrow, and I want a nice Thanksgiving gift for you to be a good grade on your quiz. No, I want you to earn a good grade on your quiz. Try this one. 2 times the square root of 500. And 5 times the square root of 20. Try those. You found your homework? Find somebody who made 100 and grade it. They're all at the desk still. I haven't picked them up. Yeah, if it's even, you always want to start with 2. And if it's even, you divide by 2. Until you can't divide by 2 anymore. This is what we did. This is what your quiz is mainly over, plus the homework from today. Like this? Okay, well that's what we're doing right now. So you want to... This 2, you're just going to multiply it by... What? Yeah. Yes. 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 Okay, so you're confusing, I think, the CBA where they had you like rewrite the question. They had you turn this back into the question. That's not what this is. This is, we're going to keep simplifying. This isn't simplified all the way. 500 definitely has some perfect squares hiding in there. So we're going to find the rest of the perfect squares that were in there. Yeah, 500 should break down. It should have 2 perfect squares hiding in there, a 4 and a 25. Yes, you could either do them separately. I usually combine them back together to make an even bigger perfect square. What's 4 times 25? 100. So 100 is actually the biggest perfect square in there. Don't you agree 100 times 5 is 500? 100 is a perfect square, and it's absolutely the biggest one in there. What's the square root of 100? 10. So it's going to come out as a 10. However, there was already a 2 out there. So now I have 20 out there, and what's inside is 5. All right, next one. 20 does have a perfect square. This one doesn't have as big of a perfect square. What's the only perfect square hiding in here? A 4. So 20 can be written as 4 times 5. The perfect square of 4 is going to come out as a 2. And there's already a 5 out there. So now I have 10 out there. And what stayed in? 5. Okay, now I think what you were confused about was on the CBA you had something like this. Well, that's simplified already. How do I know it's simplified? Yeah, there's no perfect square hiding in that 2. 2 is not a perfect square. What they asked you to do on the CBA was basically go backwards. What was the question before it got simplified? They want you to put the 3 back in there. Well, it's going to go back in as a 9. So this would be the square root of 18. What about 5 times the square root of 3? What would that be? Right. So you should be able to go backwards as well. This 5 would go back in as a 25. Okay, now your homework. I am going to just put it up on the screen. It will be on Schoology because the video is being recorded. At the end of the video will be the homework. Or you can copy it down right now, or yes, you can take a picture. This is your homework. Yes, you can take a picture of it. I'm going to leave it up here. I'm about to stop the video. I'm going to leave it up here. You've got 15 minutes to be doing your homework. And also, if you don't have a phone, it is going to be on Schoology, or start copying it right now.